All right, this is going to be a video on the graphing technique. It's basically how to use a graphing calculator to solve equations, to find the answer from the solutions for equations. So the first thing we're going to do is we're actually going to revisit those same equations that we had in the last video. So we had that first one that was negative 2x squared is equal to 4x minus 6. Now, and to solve this using graphing, what you're going to need to do using your graphing calculator is you're going to want to hit y equals, and you are going to want to put for your y1, you're going to want to put the left side of the equation. You're going to want to put that expression into the y1. So you're going to put negative 2x squared. Okay. The second one for your y2, you're going to want to put negative 4x minus 6. Okay. So I put the left side of the equation on the y1, the right side of the equation on the y2. Okay. From here, you're going to hit graph. Or hit trace, either one. So once you graph it, you end up with something like this. Now, what we are looking for using the graphing technique in order to solve this is we're looking for the points in which this y1 graph, so this blue, intersects with this y2 graph, which is this red right here. So we're looking for where they intersect. Now, if you notice, they intersect here, but they don't actually show where they intersect over here. And that's a problem. And I kind of use this example on purpose to kind of show you what to do when that happens. So this first one should be really easy to find where they intersect. The problem is this one right here. So the first thing that you're going to want to do is make it where both of them actually intersect, and you can see it on the screen. Okay, so what we're going to do is we are going to go to our window. So our y right here doesn't go down far enough, so we want to make it a little bit further down. So we're going to actually hit y, this window button right here, and we want to go to the y min. What we want is that y min to be a lot less than negative 10, because if you go back to the graph, it only goes down to negative 10. We want it to be, I don't know, try negative 20. Also, we don't actually need this y up here. If you can see it's right here, it's this positive y, because this one's right here, it's underneath that x-axis. All right, so to do that, to make it so we can actually see where they intersect, you want to go to window, and then you're going to want to go to your y max. You want your y max to be 0, because we're shifting everything down, and then you're going to want to change your y min to negative 20. So we're basically moving the whole coordinate plane down 10, so we can kind of see this a little bit easier. Once you do that, just hit graph, and then it basically moves the screen so it looks like this. And now, as you can see, we see that first intersection right here, and then we also see the second intersection here. So that's step one. If you're going to be using your graphing calculator to find solutions, is you need to see where they intersect in all places on the graph. Okay, well, this is linear, so we know it's going to constantly go in this straight line here, and then this is quadratic. So because of that, there are two solutions for this particular problem. We don't need to worry about there being any other parts where this intersects. Okay, from here now, to find this exact point where it intersects, what you're going to want to do is hit second calc, and then you're going to want to go to number 5 where it says intersect. So number 5, and then hit enter. Now then it says first curve. We make sure your first curve is that y1, and then you're just going to hit enter. And then your y2, make sure it is that, it says your second curve, make sure it is that y2, and then hit enter. And then it says guess. Now the reason why it says guess is so it kind of guesses which one you want. Do you want this intersection or this intersection? It only does one at a time. Unfortunately, it would be awesome if it showed both of them, but it doesn't. You have to literally do this one at a time. So for this guess, you're going to want to be closer to the one that you want to look at. So if we want to look at this one first, you're going to want to go closer to this one. So I'm going to go a little bit closer to it for the guess rather than this one. So get closer to this one. Now, if you just hit enter, it's going to find that intersection point right here. As you can see, -1, -2. So that would be the coordinate for where they intersect. Now, if you remember the answer for one of the answers anyway, when we solved that original problem, that -2x squared equals -4x minus 6, when we solved that, we actually got x is equal to -1. So this actually matches that first method where we use the quadratic factoring technique, so that this graphing technique does show that same answer as the factoring technique, which is good. Okay, now let's check this other one. So you're going to have to repeat the process, second calc, and then you're going to want to go to intersect. So that's the 5th choice. So hit number 5. And then it says first curve, make sure it's the y1. Then it says second curve, make sure it's the y2. Hit enter. And then it says guess. You do not, so it says guess right here. You're not going to want to be closer to this one, so you're going to actually move over. So it's closer to this one. Now, as you can see, it's definitely closer here than it is here. So you should be good. Then hit enter. And then right here it says intersection at 3. Now, if you remember when we did the quadratic factoring technique for that first problem, 3 and -1 were both the answer. So if you actually use the graphing calculator, you will see that you actually get the exact same answer that you did with factoring, but you don't have to actually do all the work. You just kind of have to mess with the window a little bit and then do some calcs that some second calc intersect to try to figure out where those intersections are. Let's try this on the other two problems. If you remember the other two problems, we couldn't actually factor them, and since we could not factor them, we weren't actually able to solve them using zero product property. The great thing about the graphing technique, though, is if there is a solution, it will find that solution. So that's what we're going to do for the next one. So if you remember the other equation, the second one was x squared minus 6 is equal to -1. So what I'm going to do is go to my y equals here. I'm going to clear this out, and I'm going to write x squared minus 6x, because that's the left side of the equation. And then on this second one right here, I'm going to clear this out. I am going to put that -1 in because that's the right side of the equation. Okay, now if you remember from before, the graph was actually, we kind of changed the settings of the graph. So what you're going to want to do for this is just hit zoom 6 to kind of reset where the graph is. Otherwise it's still shifted in that weird way that we had it last time. So I'm going to start with zoom 6 here, and then I'm going to graph this out. And as you can see, there are two intersections right here. We don't need to mess with the window or do anything like that. It kind of already did it for us, just based on having the standard graphing right here. So we have a solution here and we have a solution here. Now to find those solutions, what you're going to need to do, again, second calc 5, because that's the intersect. Okay, then from here, first curve is y1, second curve is y2, and then it says guess. We're closer to this one, so let's hit enter. Okay, so now we actually have an answer. We have that x is equal to 0.171572888. It just kind of keeps going right here. You could kind of tell it's an irrational number just from this answer right here, and then the y is equal to -1 here. Now, one of the great things about graphing technique is that it does give us an answer. One of the downfalls of graphing technique, however, is that it only gives us an approximation. So this is an answer, but it's only an approximate answer. It's an approximate solution. It's not the exact answer, but it is great for checking your work. And it is great if the problem says just use graphing and find the approximate answer. So this would work if we're only doing the approximate. Again, you're not going to. There are some questions where it's going to say the exact solution. That being said, let's try to find this other solution over here. So we're going to do second calc 5 for the intersect. First curve, yes. Second curve, yes. Good. And then now guess. Now we're going to have to move this all the way to the other side here, so it's closer to this intersection. Hit enter. And then it tells us this intersection. And again, we have another irrational number, a number that basically doesn't really follow a pattern. It's just a bunch of decimals that just keep going on and on forever. This is not an exact answer. Again, this 5.8284271. But again, it's an approximation. So that's basically what graphing technique shows us. Again, it's more of an approximate answer if it does not come out exact. We are going to be going over techniques that do give us the exact answer, though. So it's kind of important to understand the limitations of each of these techniques. Okay, the quadratic factoring technique, its limit was when you couldn't be factored, when the equation could not be factored. This limit is when you want an exact answer. Let's try the third one. Maybe we have, maybe there's some interesting results on that one. All right, so it's -x plus 3 is equal to -x squared. So I'm going to put the left side of the equation up here. So -x plus 3. And then this y2, I'm going to clear this out and write negative. I'm going to write -x squared. So my y1 is going to be this -x plus 3, and the y2 is going to be -x squared. And then from here, I'm just going to hit trace, or you can hit graph, either one. They'll graph it out like so. So there's my y1, and then here's my y2. Now you should notice an interesting thing that happens with this one is that they don't intersect. And not only do they not intersect, they will never intersect, okay? So if you notice in this window right here, this one's going down forever, and it's going down where it's never actually going to intersect with this. This one's going to get further and further away from this one right here. Same thing with this one. This one's not ever going to intersect it anywhere here. So when this happens, now this is the great thing about graphing technique, it shows you when there are no solutions. So if there is no intersection, there is no solution. So there are no ways of actually solving this equation using real numbers. We'd have to use imaginary numbers, but that's in a totally different math class that we don't need to worry about for this class. So that's basically how to use graphing technique to find approximate or exact answers depending on the problem. Again, if it factors out easily, you're going to get those nice, easy numbers. If it doesn't, then you're going to get these irrational numbers that you can find the approximate answer for, but you're not going to find the exact using using the graphing calculator. We're gonna have to use some other technique for that. So if you have any questions about the graphing technique or anything else that's in this video, let me know.